Hi students, we will see about N-body solver. N-body solver is a program that is related to molecular dynamics, which deals with the movement of the molecules and atoms over time. So here we are going to see about how we are going to parallelize the program in order to compute the different positions and velocities of different atoms, and also we are going to see about the MPI algather, multiprocessing algather, where we are going to gather all the computed positions and velocities of different atoms or molecules. So while starting with, we are going to handle the particles by means of assigning different blocks for computing different particles, velocities and positions. We have to take into consideration the memory. While we are going to store the data, we should see that it is stored only once. No repetition and also no wastage of memory. So at the starting, the particle's position has to be initialized. Maybe we can assume that initially the particle's positions are known. Next, we have to broadcast and scatter the data, scattering data in order to make all other atoms to be aware of different atoms' positions in the code. So then we can see about the pseudocode for solving the N-body solver program. So what are the steps in that MPI program and how we are going to calculate the global position and the velocity of the atoms, particles. So then we, we are going to see about the different formulas that is used to compute the positions and velocities of the atoms. So here we are using the Newton's law F1, 2. So I am taking 1 and 2 different two atoms into consideration. 1 and 2. I am considering only two of them in the whole mass, whole particles. So there may be many particles. I am concerned about only these two. So how I need to calculate the forces? Force between these two particles is given by the, it is equal to gravity mass 1 mass 2, mass of this atom, mass of this atom, divided by the square of the distance between them. What is the distance between them? That is squared. So this formula is to calculate the force that is acting upon on an atom. From different atoms we can compute by means of repeating this formula. Then after that we know the force for a particular atom and know the mass of that atom, we can find the acceleration. When we know the acceleration value, we will be able to calculate the velocity value by means of this known value acceleration and also the known time period in which we need to calculate the velocity. Then after knowing the velocity, we will be able to calculate the distance. Distance tells you will give you the position. Hence, we will be able to calculate the position and velocities of the particles. So to start with the pseudocode, we will get into this sequence. So that is getting the input data. What are the input data? What are the number of atoms and what are their initial positions will be the input data, and what are the masses of different atoms. So then for each time step. The time step can be given by the user. So at that time step, what is the position, what is the velocity? If that time step is reached, the position and velocity can be printed out. For each local particle, we are going to compute the force. For each local particle, we are going to compute what is the force on that, and later on what is their position and what is their velocity. So those will be computed for that particular local particle. And after calculating like this for all the atoms, it is gathered into a global position array. So where we are going to store all the positions and velocities of different particles or atoms. Then we are going to print the global positions and velocities of those particles. So this is how the n-body solver program is computed by means of using the multiprocessing. So the workload is shared between the processor and it is computed. Thank you.